All right, so topic C is about finding missing sides in right triangles. So you now know what it means to have trigonometric ratios. We're going to use these ratios to find missing sides in triangles when we know how big angles are in these right triangles. So before we can do that, let's just write out our ratios again for sine, cosine, and tangent. Remember, it's some old horse caught another horse, taking oats away, or SOHCAHTOA, or sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first question says, find the missing sides in the following triangles, round to the nearest thousandth if necessary. So the angle that's given to me is this angle up here. I know it's 35 degrees. So everything is based on the angle that I know. So I know this 15 right here as well. This is going to be the hypotenuse because it's always the hypotenuse, okay? And how is this x related to this angle right here? Well, it's the side that's opposite it. So which trigonometric ratio uses O and H? Let's look back at what we have here. Is it sine, cosine, or tangent? It's sine. The sine of any angle is always the opposite over the hypotenuse. So I'm just going to write this in the corner just so I remember that sine is opposite over hypotenuse. So basically what I have to do is I have to take the sine of the angle that I know, which is 35 degrees, and say that that's equal to the opposite, which is x over 15. Once I've done that, I'm done with the trigonometry part. All I have to do now is just solve my equation. So basically all I have to do is multiply both sides by 15. Now be careful. This means that this is the sine of a 35-degree angle. And I think we've discussed this before, that it doesn't mean sine times 35. It means the sine of a 35-degree angle. But this means 15 times sine, which means that this 15 cannot be multiplied by this angle right here. I'm going to take the sine and then I'm going to multiply that by 15. Basically, all you have to do is literally type this into your calculator exactly how you see it. So you just type in 15, write the multiplication sign, type in SIN, open up your parentheses, write 35 and close them. Or instead of typing in SIN, don't forget that you can just choose this trig button right here and you have sine right in front of you. It's up to you, whichever one you prefer. When you type it into your calculator, you're going to get a big, long, crazy decimal, but it says to round to the nearest thousandth if necessary, which it is necessary, so you end up getting x is approximately equal to 8.604. Okay? Hopefully that makes sense to you. So now, let's look at question number 2. In question number 2, you are given this angle right here, which is 12 degrees. I want you to press pause. But before you press pause, I want you to understand what it is that I want you to do. Identify how this 10 is related to the 12-degree angle, how this x is related to the 12-degree angle. Remember, the right angle is right here. Okay, so label it. Are these sides the opposite, the adjacent, the hypotenuse? Which one of those three words is the 10 and which one is the x? Come back to me after you've labeled it, see what you get. Okay, so you should label that this 10 is the opposite because it's across from it, okay? And that this x is the adjacent because it's next to it. None of these can be the hypotenuse because the hypotenuse is the side that's across from the right angle. So which trigonometric ratio uses adjacent and opposite? Well, let's look back and see what we have. Looks like tangent is the one that uses adjacent and opposite. The order does matter, so you have to do opposite over adjacent. So let's write this down. So remember, tangent is opposite over adjacent. So I'm going to say that the tangent of my 12-degree angle is equal to the opposite, which is 10, over the adjacent, which is x. Now, my goal, again, at this point in time, I'm done with the trigonometry. Now it's just algebra. My goal is to solve for x, but I have an issue, and that is that x is in my denominator, which makes things really difficult for me. So, how do I deal with it? Get it out of the denominator. So, how do I do that? Since it's divided by x, I'm going to multiply both sides by x. My x's cancel out. I end up getting x times the tangent of 12 is equal to 10. That doesn't help me get the x by itself, but it does help me get the x in a position that's much easier to deal with. So how do I get that x by itself? Well, it's being multiplied by tangent of 12, so I'm going to get rid of it by dividing by tangent of 12. Okay? So now all I have to do is type that into my calculator. Now, make sure you type in 10 divided by, then type in TAN, open up your parentheses, 12. Okay, and then it should work for you. And you will end up getting x rounded to the nearest thousandth is approximately equal to 47.046. Okay, now what I want you to do is see if you can figure out questions 3 and 4 without my guidance. I will tell you the answers and I'll show you some of the work, but if you're confused about 3 or 4, you need to see me tomorrow in class and I can help you out with them. All right, so go ahead, try 3, press pause, and then come back to me to see how you did. So if this is my angle that's given to me right here, this is the angle I'm trying to point to. That means that the side labeled as x is the adjacent and the side labeled as 13 is the hypotenuse. I apologize, there should be a right angle right inside of there. So cosine is the one that uses adjacent over hypotenuse. So I'm going to say that cosine of my 34-degree angle is equal to the adjacent, which is x, over the hypotenuse, which is 13. Multiply both sides by 13 to cancel the 13 out, and you get 13 times cosine of 34 degrees. Literally type that into your calculator, you get x is approximately equal to 10.777. So hopefully that made sense to you. Try number 4, press pause, solve the problem, and then come back to me, see how you did. So for question number 4, the angle that we are going to be looking at is this 58-degree angle right here, which means that the 9 is opposite because it's across from it. The x is the hypotenuse, so I'm going to use sine. So sine of 58 is equal to the opposite, which is 9, over the hypotenuse, which is x. Get that x right here out of the denominator by multiplying both sides by x. You end up getting x equals sine of 58 equals 9. Now get that x by itself by dividing both sides by sine of 58, and you end up getting x equals 9 over sine of 58, which is approximately 10.613. Remember, write down your questions, ask me tomorrow. On to topic D.